sir. So to formally start, let me first introduce myself. I am Mary Lou Emanigoy, the assigned reporter for YOLO Free Reinforcing Steel. So as you can see, the topic are flashed on the screen. We have the types of reinforcing steel, need for steel reinforcement, advantages of steel reinforcement, and also we have the disadvantages of steel reinforcement, and lastly, we have the production of rebars. So to start, what is reinforcing steel? So as you can see, it said that reinforcing steel is commonly called as rebar. It is used in bridges, buildings, skyscrapers, homes, warehouses, and foundations to increase the strength of a concrete structure. So reinforcing steel strengthens and aid the concrete under tension. So it is commonly manufactured using mild or high yield steel using grade of 250 or 250 Newton per millimeter squared. So to proceed, we have the types of steel reinforcement. First is the hot rolled deformed bars. Hot rolled deformed bars is the most common type of reinforcement for regular RCC structures or the reinforced cement concrete. Hot rolling is done in the mills, which involves giving it deformation on the surface. Next, we have the cold work steel bars. These bars look similar to hot rolled deformed bars, although it is worked by rolling the steel at room temperature. Next, we have the mild steel plain bars. Mild steel is a carbon steel typically with a maximum of 0.25% carbon and 0.4% to 0.7% manganese. And lastly, we have the press dressing steel bars. This is a wire rod with a high carbon content. Press dressing steels are used in the building industry and need to withstand the highest mechanical stresses. As a result, there are special requirements with regard to tensile stress of the product. So next, we have the need for steel reinforcement. So what are the needs for steel reinforcement? So concrete is a conventionally used material for construction, while steel is now gaining momentum for its flexibility and reduced construction time. So steel, while having a high lead time, is known for its fastest erection on site. However, steel needs fire protection where areas within concrete. So next on the topic, we have the advantages of steel reinforcement. So first, we have the compatibility with concrete. So the bonding between the steel and the concrete is very important because a steel rough surface and the closely spaced ribs on the bar surface will result in a strong bond between reinforcing bars and concrete, and its possibility of slippage will be minimal, and it will result on a strong band between concrete and reinforcing bars. So next, we have the robustness of steel reinforcement. It is the ability of a structure to withstand events like fire, explosions, impact, or the consequences of human error without being damaged and extent disproportionate to the original cost. So next, we have the bend property of steel reinforcement. Also, we have the recycling property of steel reinforcement that is infinitely recyclable, meaning it typically is recycled by demolition contractors who sell the bars as ferrous scrap. The steel is reclaimed by crushing the concrete and retrieving the bars with hammers, breakers, and grappling hooks mounted on a heavy equipment. And lastly, we have the easy available. So steel reinforcement or the steels are easily available in Philippines or in other countries because it is really useful nowadays in this generation. So as contradiction to advantage, we have also the disadvantages of steel reinforcement. We have the reactive nature of steel reinforcement, the expensive, so it is very expensive nowadays. And lastly, we have melt. It melts at high temperature. It melts around 1510 degrees Celsius. And steel often melts at around 1370 degrees Celsius or 25 Fahrenheit. So now let us proceed to steel bars. So steel bars are used as a tension device for concrete construction. Since concrete is known to be strong under compression, yet weak in its tensile strength. So lastly, we have the production of rubbers. So I will be presenting to you on how rubbers are produced. Let's just see. So enjoy watching.
TMT construction bars are manufactured using the latest computer-controlled water quenching process. Here is how it all happens. Carefully selected high-quality raw materials are charged into a 25-ton steel-making furnace. During steel making, at regular intervals, the liquid metal is tested to ensure that the chemical composition is as per ISI specifications. The chemical composition must be right to get the right properties and various grades of steel, such as Fe415, Fe500, Fe550, and CRS, that's corrosion-resistant steel. Carbon gives strength and manganese provides flexibility. When the liquid steel attains 1660 degrees centigrade, it is poured into a huge refractory-lined metal container called the ladle. The liquid steel is then purged with an inert gas to homogenize the temperature and to release any dissolved gases in the metal. The ladle is then lifted and placed on a continuous casting machine, where the liquid steel is cast into prime quality steel billets. Very few producers use billets to make TMT grade steel. Billets are the most modern method of casting liquid steel into rolling stock, which helps produce steel of superior grain structure, free of internal defects and homogeneous in its properties. A simple example to explain this. Steel cast from ingots has an inherent defect of piping. Look carefully and you will see that there is air trapped in the steel, which weakens the TMT bars. And in comparison, take a look at a billet, which is continuously cast and therefore there is no question of air trapped inside. It is therefore smart to insist on buying TMT bars that are made from billets. The billets are cut and then passed through a computer-controlled reheating furnace, which ensures that there is an even temperature of billet rolling stock, resulting in better quality finished product with uniform weight per meter. Post-reheating, the billets go into the rolling mill, where the size of the bar is reduced to the desired diameter. Our rolling mill is able to provide bars of all diameters from 8 to 32 millimeters to meet all our customers' construction needs. Another critical part of the manufacturing process is that of water quenching and tempering, where the finished diameter bars are heat treated to give the desired properties. To make sure that every bar spends the same amount of time in the quenching chamber, the bars are guided into it by pinch rolls, thereby giving consistency of properties across the bar and straightened bars. The red-hot rod is sent through a chamber where water is sprayed onto the incoming bar rapidly, which suddenly changes the outer layer temperature of the bar from 900 degrees centigrade to 280 degrees centigrade. while the inner layer stays at 900 degrees centigrade. The inner layer tempers the outer layer on the cooling bed. The bar now reaches an equalization temperature of about 575 degrees centigrade to 625 degrees centigrade, depending on the grade of steel we want to make. It could be Fe 415, Fe 500 or Fe 550 grade. This forms the hard outer layer called tempered martensite and soft inner layer ferrite pearlite. The outer layer is thus hard and keeps the bar strong, while the inner layer, being soft, provides flexibility and elongation. iSteel has further improved this process and now has a new water quenching system. Since different parts of the bar entering the cooling chamber vary in temperature, computer-controlled quenching ensures that the amount of water sprayed onto the bar varies depending on the temperature of that portion of the bar. As a result, we have a bar of similar strength across the length, something that few TMT construction bars can boast of. A computer-controlled flying shear cuts the bar after the quenching process, ensuring that there are no sharp edges on the bar that reaches you. The tail breaker slows the speed of the bar after it has been cut by the flying shear onto the cooling bed. There is a twin-channel arrangement that is PLC controlled and guides the bar onto the cooling bed. Look closely at an iSteel bar and it has a surface look that is different from other bars. This is due to the CNC-controlled rib cutting machine that yields perfect rib geometry to give superior ribs and hence better bond strength.